So I'm going to talk on direct roving, memory mapping, and cache technique. But first, my name is Kwamina Aquatexin, and my index number is 2425404906. So starting with direct mapping. But first, direct mapping is a technique. So we are talking on I'm talking on direct mapping techniques overview. So direct mapping techniques are methods used in computer architecture to map main memory to cache memory. So more like mapping to the cache memory. And we have some overviews or highlights. So number one is performance. So the performance enhances processing speed by reducing access time to frequently use data and instructions. And the second one is simplicity. Utilizes straightforward mapping rules that make implementation and understanding easier for designers. So with this, it makes it really easy for you to understand. The third one is cost effectiveness. So with this, reduces hardware complexity, leading to lower cost in both manufacturing and operational use. And the last one is versatility. Versatility. So with this, it supports various applications from embedded systems to high performance computing platforms. So you could see here, I used a brain. So this is more like a brain scan, and you could see people working on technical diagrams, possibly illustrating the application of direct mapping in efficient data handling akin to cognitive processes or in designing technical systems. So moving on to the next one. The next one is memory mapping techniques. Memory mapping techniques. So number one we have here is direct mapping. So I explained direct mapping previously. So I'm just going to summarize it. So with direct mapping, it's just like it maps each block of memory to a specific cache line. So the usage of um memory mapping, sorry, the usage of direct mapping. So it's simple, but it is really simple, but can lead to conflicts if multiple needed blocks map to the same line. It is simple, but it can lead to conflict. And secondly, we have associative mapping. So with this, it is any block of memory that can be stored in any cache line. And its usage is flexible but requires more complex hardware for searching. So it's really flexible. It means it can really be changed, but would only require more complex hardware for searching. And number three, we have set associative. So with set associative, it combines direct and associative mapping. And its usage, it balances. It is also simple and it is also flexible. Also, the fourth one, we have cache replacement. So the cache replacement, it manages it manages which data to move from cache using algorithms like LRU or FIFO. And number five, we have memory partitioning. So with partitioning, it involves dividing memory into segments or partitions. So from the word partition being divided into segments. So it also aims to optimize memory usage and accesses efficiency. And let me just brief in on the purpose. So its main purpose is efficient access. Just partitions can be tailored for specific types of data or application. And lastly, protection. It can help in isolating parts of memory for security or stability. Moving on to cache write policy. Cache write policy. So with this, it determines how data writes are handled between the cache and the main memory. So moving on to the next slides. Moving on to the next slide, I'm talking on cache memory techniques overview. So my first point is reduce latency. How can you reduce latency? By storing frequently accessed data closer to the CPU. With this, it's going to reduce data access time and it's going to help improve on performances. It's also going to help reduce on performances as well. So with this, it's minimize time to access frequently used data. And how can you do that? By storing data in cache closer to the CPU. And if you are to do that, um, it's going to produce faster data retrieval and also going to help in improving overall system performances. Number two, we have increased throughput. Increased throughput. So with this one, its main purpose is to handle more data requests efficiently. And how can you do that? Or the method for doing that is by implementing efficient caching strategies. And if you are to do that, it's going to help in enhancing ability to process multiple requests, especially under high demand, And next point, we have energy efficiency. So its main purpose is to reduce power consumption. And how can you do that? Or the method for doing that is by swifting access to data in cache, minimizing energy use. And if you are to do this thing, your result is going to lower energy usage, which is going to contribute to longer device lifespan. Moving on to the next slide. So pragmatic application of direct mapping. Number one is problem faced. Um, so problem faced. How do Okay, so with this, cache conflict leads to performance degradation. And how can you improve on it? How can you improve on it? Or what's the solution to it? That's by improving direct mapping techniques. And if you are to do that, your outcome is you are going to have better cache efficiency and fewer misses. So first, I spoke on problem faced, cache cache performances degradation due to conflicts, as said earlier. And I spoke on the solution, implementing improved direct mapping techniques. And the benefits you are going to derive from it is by enhancing cache efficiency. And also it reduces miss rates. So I'm speaking on the approaches now. The approach number one, identify patterns. Sorry. Approach number one, identify patterns. So you must understand data access patterns causing conflict. First, understand data access patterns causing conflict. And number two, you must analyze techniques, analyzing of techniques. So you have to evaluate current mapping strategies. The third one is implement changes by applying optimized direct mapping to it. Lastly, we have evaluate results. How do you do that? By checking for performances. Moving on to the next slide. So this is a diagram explaining the performance analysis of memory mapping. So the L1, L2, L3 is the cache levels. That's the cache levels. And we also have cache memory hits. So that's the metrics. That's the cache memory hits. And we also have mapping techniques efficiency. So this is shown as percentages. And we also have our bars, which are blue bars, represent data for each cache level and metric. So from the diagram, we have efficiency gains. That's here, efficiency gains. So direct mapping boosts access speed by 20%. It boosts access speed by 20% from our diagram. And secondly, cache utilization. Higher hit rate means less time accessing main memory. So higher hit rate means less time. And lastly, mapping types. So associative mapping provides flexibility and speed advantages. So it comes with it being flexible and also it being fast in terms of speed. And moving on to my next slide. Okay, so impact of cache memory on efficiency. So, number one, we have is performance. It enhances performances. Its effect is it boosts system. Sorry, it boosts system speed and responsiveness. So that's the effect, and the result is better user experience and processing capability. So it really gives you a better user experience. And secondly, we have latency reduction. Its effect is that it's really fast to access. So faster access to frequently used data. And its result is it improves systems responsiveness. Moving on to the third one, that's throughput. Its effect is more data processed in less time. So you can process more data in less time. For example, your time is really minimized, but you can process more data in less time. And its result is higher productivity in computing tasks because you are going to produce more. So it means productivity is also going to increase or is going to be high. We also have the fourth one to be efficiency. Optimized efficiency. So effect is resources used more effectively. Is being used more effectively. And the result is better overall system operation. Moving on to number 5, scalability. So its effect is handles larger workloads efficiently. And its result is system update to increase demands. helps in system update to increase demands. And lastly, cost minimization. So it means it's less expensive. So its effect is balances performance with cost. And its result is in terms of economic precision and all, it minimizes overall expenses related to performances. So it's really cheap. It's really cheap. Moving on to my last slide. So future of memory and cache technique. Future of memory and cache techniques. So we have vision for advancement. Vision for advancement. Um, so what it's really focusing on is lead in developing advanced memory and caching technique. That's its focus. And its goal is to achieve faster and more efficient computing system. And number two, we have mission. So that's mission for efficiency. How does it approach? By utilizing of cutting edges memory and caching principles. And its outcome is compute enhanced enhanced computational efficiency. Sorry. And the last one is value, that's core values. And its commitment is for quality. Sorry, it's for quality, it's for innovation and excellence. Sorry, and excellence. And its impact is for global advancement in memory technology. So, sir, I want to say a big thank you for hearing me out. Once again, my name is Kwamina Koteksin, and my index number is 2425404906. Thank you so much. Thank you so much.